Hello everyone, in this video I'm going to show you something really cool that I am working on, and it's in relation with the image that you see here on the screen. They have a camera facing to the radio, and you're thinking why I am doing that, and let me show you. It's because this webcam facing the radio is capturing the readout digital display of the frequency from the radio, and I'm capturing that and converting that number and then sending that into my login software and the CAD software. And let me explain you why I did that, how I did that, and what tools I use after the intro. Welcome back to the channel. This is Pablo, VA3HDL, and let me show you how cool is this project. Let me turn back on that capture from the webcam. This is actually the output of the software, the program that I wrote, and let me show you quickly what it does. Here on the top, you can see the frequency, and now I will be changing the frequency on the radio. You can see I'm live changing the frequency of the radio on my hand, and you can see the readout is automatically updated with the frequency from the radio. This is very cool, and the reason that this is useful to me and cool is because this is an old radio from the early 80s or late 70s, prior to the home computer boom, the personal computer boom, and this radio doesn't have a CAT interface, so there is no way to connect this radio to the computer. And when I'm using it, I don't want to manually have to type the frequency on my login software when I'm making the QSOs, right, and recording them. So let me show you what the artificial intelligence tool I use to get the basis of this application and all the steps on capturing and processing the image, and how this it gets connected into the CAD and my login software. So I have this thought of I knew what I wanted to do, so I wanted to have the webcam to recognize the display of the radio, but I didn't know how to start. I have some idea. I wanted to use Python as my language, and I wanted to use specific libraries that I knew they will work for this, but I didn't know how to start. So I say, I'm gonna give it a try to this new tool. You heard about it recently, called ChatGPT. That is OpenAI.com, and it's a chat that is based on or has a back end on artificial intelligence. So I went here to that chat and I asked this question. Or I put this line: Python code to recognize digital display numbers with a webcam and OpenCV. OpenCV is the library for Python that I'm using for computer vision. CV, it means computer vision. And incredibly, you can see here that this is what I receive. So the artificial intelligence, the AI, told me here is an example of the code, right? And start typing the code for me here. So you can see all the code I received from the AI, and I say, okay, let's give it a shot. I copy that code into Visual Studio Code, and I give it a try. I run it, and you know, it worked immediately, instantly, and worked perfectly. So I was quite impressed at that point, and I say I need to continue pursuing this project. So from those original about 30 lines of code that the AI gave me, I grew the code to do few things, which I'm gonna show you, from from about 39 lines of code to about now, as you can see here, I have the code running in the background. There are 328 lines of codes now on this latest version which I'm running now. So what all this code does, I will show you that next. So here there is a visual of what the software is doing in the background. So I did a sample, or I'm taking a sampling of each step in the process, the major steps in the process of capturing the image up to the final and to the right, with the region of interest selected there in green on the screen, and on the top in red the corresponding character recognition in red. So how all this works from left to right? So on the first frame here, this is the live capture of the camera. It's a specific region of the live capture of the camera. So for example, if I move, now you can see this is live. This is not static. This is the software running in the back, right? And the first step in the image, here there are two steps actually in this grayscale image. One is first is to convert to grayscale. As you can see here, I'm losing all the color. I'm not interested in the color information for this project, and I'm slanting the image to the left. The top you can see there is slanted to the left, so the numbers are properly aligned and properly vertical, because in the radio they are a little bit inclined to the right. In the next sampling is after the thresholding process in the image, where I get the major objects, the most important, more bright objects on the screen. Then in the next one, actually this is in not in the right order. This goes here. I detect the contours of my region of interest first. Right here you see this is black. It's not detecting any contour because they are already detected. So I do this only when it's a change on the image, right? So if the image is not changing, there is no reason to redetect new contours. So let me see if I'm moving here. No, it's still it's minimal, the change. So the one thing I can do, you can see here in red the numbers are always live updating, right? The numbers recognized by the computer. So one thing that I can do to show you how the recognition of the contour works is by resetting the contour. Let me see with the R key. And doing that, you can see briefly is showing here what is the contours that is detecting. Of course, those are the wrong ones, and the reason I'm doing the automatic contour detection is because there are two ways of setting up your region of interest. One is by manually, like pointing and selecting a rectangle on your screen, and other like this one, like a semi kind of automatic, where the computer can pick up the brightest and the largest items on the screen. Like in this case, I think this is a good region of interest of all the numbers that we have, and that's it. Now the only thing we need to do is just change frequencies, and they are live updated on the top here in red. But how this gets into my login software? So yeah, that is the next part. Here I'm running a dummy cat application. It's called Commander, and what I'm doing with this one is the code is sending via network the numbers in red to the commander in here, and my login, which is here, log for all men. Let me see the live capture. Yeah, you can see it is capturing the numbers from the display. Like if I'm moving 5 and is 14146.5. You can see it here in red, and you can see it here on my lower. So at this point, I don't need to worry to manually type the frequency into my lower. I just can enter the call sign that I contacted, and I just hit enter, and that's it. I have the frequency, the mode, and all that saved automatically. Let me show you how the mode works. Let me go to 40 meters. So now I am in 40 meters, and the frequency is recognized, and automatically the mode changed to LSB. So let me go back to 20 meters. The frequency got updated, and now is now is showing USB on the commander, which is the dummy cat application that I am using, and in my lower is showing USB also. Alright, now in this part is only for the ones that are interested on the code and how all this has been stitched together and works. And I'm gonna go very quickly through do a code review and explain the different libraries and things that I use. So there is all the green stuff is all comments that I put for reference for me. Like all these are all the settings for the webcam that could be used if they are supported by the webcam. In some cases, or in many cases, not all these properties are supported by the webcam. And here in the import, we have the libraries that I'm using: NumPy, CV2, which is the computer vision library. The CV2 is the OpenCV that I mentioned earlier. I'm using Tesseract. Tesseract is the character recognition library. My understanding is that was developed by Google and is open source. I'm using, I have to install separately and install this wrapper for Python to use it in this application. I am using Socket, which is the network connectivity. And in the next two functions, the send to commander and the send to log for all men, is how I implemented sending the frequency information captured by the camera to. I have the two choices. I can pick which one I want to do. I either send it to commander, which is that dummy cat application, or directly to log for all men. I choose to send it to commander because I can tap from other applications also into that dummy cat and then read the frequency on the other applications. Then in this function, I check if the frequency is in the valid ham range, amateur radio range, and based on the frequency, I set up the band in meters and the proper sideband or mode. The rest of the functions is all the processing of the image, brightness processing, capturing the webcam, setting up the OCR library. This is a loop that I'm not running. I'm using this loop sometime when I need to tweak the camera, but right now is out of the code. And this is the main loop. This is the one that I'm using. I'm capturing the webcam frame and doing all the processing, the affining, which is this tilting that I'm doing to the left to put the numbers straight. Then I am doing some resizing of the image. That little section of the numbers, I increased the size to 200% to send a big image to the OCR. I'm converting to grayscale, picking up the threshold that is helping to identify the the contour. Once we have the threshold, we can identify the contour of the big numbers to detect the region of interest. Once we do that, once we have all the contour, I take 1,000 samples of the contour detected and set up the region of interest. So as you can see here, once the region of interest is set up, the coordinates where the numbers are, I don't change those numbers again. Then after that, I put the numbers on a bigger canvas with a white background. It's better for the optical recognition library to have it that way, I found. And here I'm doing a couple of passes with Tesseract, the OCR library. The first one is to convert to string, and the second one to give me that square where the numbers are located, or where the Tesseract is doing the conversion of the image to text. So I can that box, I can put it back on the image, and I can see where the OCR is detecting the numbers, and I can see if it's detecting the number from the place that I want to be detected. Because on the displays of the radio, there is a lot of other information that is not needed. I want to make sure the OCR library is not picking that information. And after that, before we close the loop, the only thing I do is I just put all these intermediate windows just to have a sampling of the image processing, which in the end product those could be removed, right? Those are not needed to run all the times, because right now I am in active development of this. I am almost there, but I think there are a little bit more tweaks that can be done. So once I done all those, I will not remove all these intermediate images. And before I close the loop, I just sample the keyboard just to see if the R key is pressed. If the R key was pressed, I reset the region of interest with like I show you at the beginning. And if the letter Q is pressed, the loop ends and the program finish. And this is important to finish properly with the letter Q, because that helps to memorize the position of the windows. For some reason, this is when Windows recognize where you last have the windows set up on your screen, and it's good when you run the program again, the windows appears on the same place. And that's it. This is all the code. It's not too complex. The only part that I spent a lot of time, and it was hard for me to do it because I didn't know how to do it, it was to train the OCR part with the characters from the radio. So in this part of the video, I'm going to talk a little bit about the optical character recognition, and the language file that I use is this one I'm showing you here on the screen. It's a language file that it was created to do the display, the typical LCD display readings, which you can see here is called the 7-segment display, which is not too close with what we use on the radio that I'm showing you here. So this is with my other radio. I started with my other radio, and then I try with the Kenwood. So I try with Yeso and Kenwood. As you can see here, it's working fine with both of them. This is with the first one, and it's recognizing the numbers on the display. But the reason that now in this picture I'm showing you is working after a lot of back and forth is because it was, in my case, it was confusing the 8 with the 0 and the 0 with the 8 using this language file that I have here. So I have to retrain the character recognition software for the radio font, if you want to call, right, which is looks like this one here. And how I did that is I took samples like this one. So I took a couple of samples like this too, and I set up the text that these two pictures contain. So in this case, the text containing in this picture is 1, 2, 3, 4, 5, 6, and in this one 8 and all zeros, because those are the characters that I have more issues to be recognized, and I retrain and make the optical character recognition software to relearn these fonts. And after I did that, the issue was gone, and I didn't have any more problems getting any characters recognized. On how to do that, if you're interested, there are a lot of videos in YouTube that you can search for, but I can put a couple of links on. I want to leave a couple of links in the comment section if you're interested in that type of details. This was part of other tests that I did for the character recognition. I tried to recognize an LCD type of display from my UHF radio, and as you can see, it works also without any issues. This is one of the pictures from the early versions of the software. Alright, that's everything for this video. I'm gonna leave you with how we started with this working and showing you one more shot. I'm moving the dial here, and see immediately it gets recognized the frequency, and in the capture in red you can see it on the top. So it works all the times consistently, and I'm pretty happy with the result. So please let me know if you're interested in learning more about this project. If you want to see more videos on more details of different parts of this project, no problem, I can do that. If you like the video, please remember to click on the like button, subscribe, and thank you for watching. Until the next time.